So hello everyone, I'm going to talk about time series analysis in R, and I'm going to put a special focus on hidden Markov models and our use case of how we use them. I've used it to analyze emotional reactions to video clips. And I'm Ágoston Török, as was already introduced. My Twitter handle is there, and I'm a data scientist at Cinetic. And our slides are available on GitHub. You can see the link over there. So later, if you want to check how we've done it, just experiment with the code. Time series in a nutshell, a series of data points in time order. And there are several different methods for unsupervised learning of time series, season trend decompositions like loss decomposition, autoregressive modeling that's very familiar with people in econometrics, and there are state-space models, and I'm going to talk about them. You can see, for example, a time series, a flow of denial on around 100 years that's built in dataset in R, and how we can get use of hidden Markov models. So, hypothesize that there are latent states, and because I took the example of denial, let's hypothesize that you have an assumption that the pharaohs who built the biggest pyramids were able to build those pyramids because the flow of denial was big and not because they were more friendly with aliens. So we have latent states that we can't observe the yearly flow of the Nile 3,000 years ago. But we actually have a series of observations that we can use to infer these. For example, let's assume that we managed to cut out a tree that was 3,000 years ago, 3,000 years old. And we can use the rings of this tree to study the rain in those years, 3,000 years ago. We also know today that rainy years are followed by rainy years with a certain probability, and dry years with another probability. And you can see that there is a probability transition matrix that is as a state-space diagram, and as a matrix can be represented. And, there has to be some magics there, but it's gone, it seems. But anyway, there are passes between the model, the observations, and the latent states, forward and backward passes, and you can use any two to infer the third. Human biosignals are also a very good use case of hidden Markov models. And actually, we are not the first ones to use hidden markers to study human biosignals. Sleep cycles in EEG has been analyzed by this unsupervised technique. Also, eye movements and how facial recognition is done by a human has been studied using hidden Markov models. And as a third use case, cardiac events has also been explored using hidden Markov models. Our question was, can we use hidden Markov model to recognize emotional states? And we have results available that assume that that state and prove that the physiological background of emotions is different. So based on the physiological correlates, we can identify an emotion with a certain probability. And it is reasonable to say that the transition probability between different emotions is different. So for example, if you got proposed, then it is a bigger probability that you are becoming happier than becoming sadder. And some emotions last longer, for example, fear, and others fade rather fast, like surprise. And just heading back to the presentations of Andrew, emotions are just as easy to access as any Higgs boson. So it is around us, it affects our life, but scientific study of emotions is a rather tough choice and a rather tough thing to do. We used the physiological recordings of 62 participants, their reactions to the Paperman video that was a Walt Disney Oscar laureate video back in 2012, and we recorded FEA, RMSSD, and NSCR. These are certain physiological correlates of EG and skin response and heart rate. And as you can see, it may not make more sense to you than for me. The physiological reactions, time series-wise, doesn't show a very good pattern. So based on just looking at these lines, you may not know what was the certain emotional states of the viewers. This is where the hidden Markov modeling comes to picture. We use the DAPMIX S4. There are several other packages in R and in also other programming languages, for example Python, to study hidden Markov models. But certainly with the greatest freedom, this is the dependent mixture model based implementation by Visser and Spakenbrink. It is a good implementation because you can introduce custom constraints, covariates, custom distribution families, and it differentiates between the prior, the transition, and the response model. So for example, you can see the dependent mixture without the time dimension of two distributions. And why hidden Markov modeling is useful. You can say that this bomb is one state. This other bomb is another state. However, you might be in problem when you have to define those cases in the middle. So in that case, the transition probability is very handy. And we used DAPMIX S4, as I mentioned, but before going on, let's remember that this is an unsupervised technique, and you have to be cautious because this fitting algorithm does not necessarily uncover emotions. It might, and if you do the setup properly, it will, if there are emotional states in the physiological reactions, but the setup is very important now. As you can see in the code chunk, we define that we expect around 4, and exactly 4 now, number of states, and the dependent mixture model says that there are 3 response variables, the observations, and we specify that we assume that everyone started in the physiological state of 1, and we set up for the transition start probabilities just random variables, and for the ease of this use case we just specified Gaussian distributions. But for example, if you use reaction time, you can use X-Gauss distributions also, and several other distributions. As you can see, it is done, fitted the model, and it converged. We are very lucky. Now, let's see the summary of the model. You can see that the initial state is specified by us, and here is a transition matrix. You can see that the diagonal, the eye of the matrix, is very strong, so the self-transition probability is very high. It is expected if these states are long. And you can see that the response parameters were all Gaussian, and you can see that the response variables have different means and different standard deviations. Let's see if it makes sense. we have a behavioral correlate because the same people watch this movie a second time. This time we ask them to do button presses to signal if they feel something positive or something negative. You can see that this curve is the summoned feeling, and the colors denote the different states. And there are certain sketches of the timeline, and this is the 6-minute long video. You can see that there seems to be some kind of relationship between the colors and their average reactions. For example, the red is only available at the end of the clip, where this is exactly, if you go and look the video online, you can see that the red moments are when they finally meet and they decide to give a chance. Also, the blue seems to be a rather negative emotional state. And if you go for the average values of the physiological responses, along with the behavioral correlates that I stress again, it was on the second view of the film, so it must be not a one-to-one correspondence. You can see that the blue state was indeed negative in the button press responses, and the red state, for example, that was really positive. And you can see also that both the means and the standard deviations were different for the emotional states. So, in conclusion, we can say safely that we were able to uncover certain emotional states, and these emotional states made some sense. And what is even better, so the unsupervised method made a good consistency with the self-reported data based on the button presses. You can define future directions as everyone experiences emotions differently and to different materials. You can use distinct hidden Markov models and distinct observation probabilities for different people, and personalized content, storyline of film, and what is even better, you can use this for targeted advertisements, and this is what neuromarketing does and what we do at Synatic. Thank you.
Thank you very much. Questions?
Yeah?
Would you be sure to use similar things to predict
I'm sorry, could you speak a little bit louder because...
would you be sure to use this kind of setup in predicting some physiological changes in connection with some health issues?
So if I understood correctly, can you predict some physiological change? So can we use physiological reactions to predict health issues?
Yeah.
Yes, actually people are experimenting on this topic, and this was one use case of the hidden Markov models in heart rate, but also, for example, it has been used to detect epileptic activity and epileptic seizures also. So it's definitely a good use case.
Thank you.
All right, let's thank Ágoston again.